Now let's talk about odd functions. Let's assume that we have an odd function, and in this case, our leading coefficient for our odd function is actually positive. So what is going to happen? Let's assume that our function is f of x is going to equal to x cubed. Now, like we did before, let's do a little table to see what actually happens. We are going to have our x and our f of x. Then we're simply going to plug in some points, which are -2, -1, 0, 2, and 1. So let's see what happens. If I plug in an f of -2, I am resulted with a -2 cubed, which in this case is -2 times -2 times -2, which is -2 times -2 is +4. +4 times -2 is -8. F of -1 is going to equal to -1 cubed, which in this case is -1 times -1 times -1, which is -1 times -1 is 1 positive, times another negative is actually going to be -1. Then f of 0 is simply going to be 1 cubed, which is 1. 0 cubed, which is 0. F of 1 is just going to be 1 cubed, which is 1. And f of 2 is simply going to be 2 cubed, which is 8. And so we result with something that looks like -8, -1, 0, 1, and 8. If we look at this graphically, we can see that on our negative spectrum, or when our x is negative, we actually have negative numbers, meaning that we're going to start off here somewhere, and we are going to go something like this. Okay? What this means is that our end behaviors are actually different than our end behaviors in our even functions, right? Our end behaviors are actually up and down. What does this mean? It means that it's up on the right and down on the left, meaning that as x approaches infinity, this means that x is going towards the right. My f of x is approaching infinity as well. Thus, as x approaches negative infinity, or it's actually going to the left, my f of x is approaching negative infinity as well. Notice that in this positive case, we have something that is very similar. If I'm approaching it to the negative number, it is negative, and if I'm approaching to the positive number, it's positive. On the other hand, when I have an odd function with a leading coefficient that is negative, what happens? So let's see. So this is like if we had a function f of x is going to equal to -x cubed. If you notice, the only addition that we're doing is this negative sign. If we look at our table again directly, but this time I'm not going to do the computations, we can see that if we put the same values, -2, -1, 0, 1, and 2, we have something quite different. When we place a -2, we actually result with a +8. When we place a -1, we result with a +1. A 0 again is a 0. A 1 in this case is going to be a -1, and a 2 is going to give us a -8. Thus, if we were to graph this, it would look something like this. So let's say that we have a graph. Remember, in this case, our negative x values are giving us positive f of x values. Thus, we would look something like this, where our end behaviors are very different than what we saw before. If you notice, we can see that these ones are going to be down and up, meaning that as I'm approaching x towards infinity, I'm actually going down towards negative infinity. And as I'm approaching x towards my negative infinity, I'm resulting in a positive infinity. This is exactly what we see. So in other words, if we want to put it in context, as x approaches infinity, again, we're going to the right, we are resulting in an f of x that is approaching negative infinity. And if we're approaching x towards the negative infinity in this case, meaning that we're going to the left, our f of x is approaching positive infinity.